Hmm. Oh, is it working? Yes, almost. There we go. All right. Hello. Hello.
Twitch.
Yeah. Yeah. Seems to be working. All right. Cool. So, yeah, we've been doing a lot of lean, using tactics to prove things and even building our own. Well, here we use tactics to prove things, but we've also built our own tactic. Where is it? Here we go. And today we thought it would be nice to show the differences between Coq and lean and try to write like a cheat sheet for Coq users who want to try lean, just like what tactics are the same, which are different, and just try to collaboratively write a cheat sheet. So for everyone who's tired of Coq, they can try something else. Yeah, that'll be the last inappropriate comment on the stream.
So, I'm just about to hit the flag button.
Yeah. No,
So I'm the only viewer at the moment. So how does one? Oh no, we have two. Assuming.
all right. Yeah, but it might
I don't
be
even know how you report this.
but yeah, pretty sure some more inappropriate comments are coming. So yeah, hang on to your seatbelt. It's gonna get crazy. Okay. So okay, let's put some ideas. So I'm thinking maybe Coq and Ari might be a nice
Yeah,
place.
so page
to start.
15 has this table.
Page 15.
Yeah.
Let's see, 11, 12, 13. Which 15?
There, scroll up. No, so the numbered page. Oh, man, of course, we have different versions.
Numbered.
There's a table.
Oh, yeah.
There's a table. There's the table. Is yours on page 13?
Yes. Interesting.
Okay, mine has 2 extra pages somehow.
Oh, okay. I didn't know there were different versions. So that's.
Yeah, this looks like it's version 6.
Okay. And mine is. Does it have version at the top?
I'm just trying to see. It's in the URL. 4.3.
Mine is 19 October 2017. So it's a good chance you have a newer one.
Yeah, mine's 27. No, it's still 2017.
Okay.
Who knows? Anyway, we have difference. But this table is the same, at least.
Okay. Okay, so we want to talk about these things at least. So maybe
yes.
I'll start by just creating a list.
Yeah.
So apply. Oh, I see. Okay.
So if your hypothesis, so it's the implication. If the hypothesis,
if you have an hypothesis H, then you can apply it. For all, you can apply it. Even and you can eliminate it. You can case it. Okay. I see. Interesting.
So like in Lean, you still have apply, but then for instead of elim, you've got cases.
Yes, but do you have cases for not, for example, here? So and exists and or.
So or you can use cases as well.
Yeah, I think so. Yes. Yes.
You just have two cases, and you have one case.
So I'm wondering, is it necessary to table it like this, or if we can just list the tactics and then just go down them and go like, okay, this one exactly.
Yeah.
I'm hoping we can get away with that.
And then split.
Yeah. So okay, so how about I just make a list out of this table. We just go, we need to talk about apply, we need to talk about intros.
Yeah. This is at least the start.
We need to talk about
elim
case. Sorry
split.
for this destruct.
Yeah.
Split. Left, then right.
Yeah.
Exists. That's going to be fun.
Yeah.
Rewrite and rewrite. Reflexivity and ring. Okay, so we at least need to talk about this.
Yes. And what else do we have?
I think it might also be useful to have some basic proofs that are done in Coq and in Lean. So some of these that we can just take from this Coq in a hurry. And we just copy and paste the Coq one and the Lean one. And then we just play with these basic tactics just to make sure they kind of behave the same. Because there might be something to say, like, oh, these are kind of the same, but they behave differently. For example,
yes,
exact is another one. See, like,
yeah,
that's a good catch there. Intuition. It's not actually used that much.
We use that, but like assumption.
Yeah, assumption.
Yeah.
I've rarely used intuition. Like, I don't think.
No, maybe that's something we'll learn from Coq in a hurry.
Yes.
And we should be using
inversion, subst. That's
we want to do simp or CBN.
Is it what is it in CBN?
We would think we should use. There is a simple,
It's like this, right?
Yes, but at some point we learned that you should use CBN.
Yes.
Instead of simple, but
yeah,
I don't remember why now.
Okay.
I mean, unfold is one that's used a lot.
Yes. Wow, this is a long list.
Contradiction, discriminate.
Oh yeah. Yeah, definitely.
And then it's a bit more niche, but useful is discussion of how we do the generalized dependent stuff.
Yes.
That's very. We have an example of that. I don't remember how we do it in Lean, but you need to know it.
Yeah, we did do it.
And then there's, I guess, remember.
Oh yeah, that's so important. I hate it. That's so
what else do we have? Let me have a look as well.
Oh, induction.
Oh, yeah.
It's like, how can you forget?
Oh no, how can we forget that one?
Yeah, I just, we have our old Coq repo as well to see like what we used to use a lot.
There's also pattern matching, but it's only a very short section.
Yeah, like in Coq you don't. You just well, I guess
It says 6.2 in Coq in a Hurry, but it's just like one paragraph. And it's just about using it in that match in a definition.
Yes. Yeah, there's definitely something to say about like like how it's much more you use pattern matching much more in Lean than you would in Coq. Yeah, so it's nice to have an example at least. Yeah, that's good. But yeah, we don't code. Yeah, let's try to focus on the tactics because it's going to be tough enough without doing syntax. But like, I think let's probably include pattern matching because it is so used so often in while you do tactics in Lean, where you wouldn't do them. Like you wouldn't write this match in between tactics and Coq, but in Lean you would. Like,
yeah, you can just mix it.
You just mix it so much.
Yeah.
So actually refine. There it is. That's
yeah.
So you would have to write the refine tactic in Coq, and then you write some Coq with some gaps. But in Lean, you just write the code, and you don't. Yeah, it's our section to write, but a very interesting one. Okay, let's find a proof, and then let's do that.
I think the proofs on numbers are always very nice.
Yeah,
like nice, easy starting points.
Good idea. Well, actually, no, because in Coq you just go, oh, Leah. Like, so maybe that's another one to mention. We don't have a good replacement for that. And maybe someone corrects us and we get a good replacement. Like, so I would start with the logic stuff if that's okay. And then we work up to some numbers. Because then with numbers you get to do induction, where with logic you don't really. So
the logic will cover this table that we had before, where you got your ands and ors and how you do the split and the destruct and so on.
So this one looks pretty painful. So let's do this. It has a few tactics.
Right.
So I'll make a. Let's see. Canada and Coq and Lean in the same folder. Yes. Okay, that's good.
Impressive.
Okay, so we get to cheat with the Coq side because it's all here. So let's do that. We're not here to challenge ourselves. Writing this up is challenging enough. And then I don't know why you need intuition. I'm going to try to get rid of that.
The split is give you two like split will give you two goals. So you need to do an A, a B, and an A. Yeah.
Why? What? Why would you lose
H1?
There, it's the struct, right?
Yes.
And then you go, okay, let me do the first case. H2, and then I get here and it's like, no.
Because the split has introduced 2 sub goals. So when on line 6, you're actually in. You're already in the left.
Okay.
You need to do the destruct before it. Yeah.
Yeah, let's do that.
That's confusing.
Yeah, they wanted to show off intuition. That's right.
Yeah.
All right. Cool. And yeah, so that's our first one. And now let's do that in lean. Lean.lean. Well, maybe let's just maybe cheat. So also we need a title for this. So I was like, tired of old Coq, trying new, fresh, lean. No.
It's too late now. That's on the internet.
Okay, it's on the internet. Okay, cool. We'll
It can't be removed. This is where my colleague tells me, oh, if you did this in org mode, you could have both languages in the same file.
Oh.
But no, I'm not there yet.
No. So we do need some syntax for lean. Can we just start in a file? I can't remember.
Yes.
Yeah, we could just start. Okay, so I just did something.
You got like a prelude.
I just did something wrong. Theorem, that's the word.
Yeah.
Or theorem.
Wait.
Yeah, there we go. And then can go for all prop
EB
colon equals by.
So now we have to do intro. So intro is the same, but just
something still
intro.
Okay. Oh wait, I can't. I have to do something lean.
Confused.
There we go. All right.
Okay, and then what do? We do cases. And yeah, with, I think. And then the pipe for the 2 cases. So
pipe.
Yeah. So new line, pipe, and then in L is the.
Oh.
You have to give it a name, H1, I guess. And then another one in.
I don't know.
That's not it?
Yeah, I think H is an and. So I think it's and of intro.
Oh, this is, sorry, I thought we were doing ors. No.
I think. Oh.
Yeah, we're doing ands, so there's only one case, yes.
Oh, I can't, that doesn't work.
So
interesting. Just looking for an example. I think we just did.
So you can do, yeah, intro. So you can do cases, and then just intro.
There we go. Okay. Okay. Oh yeah, this is the thing. It can't be qualified. So okay. Yeah. And then we still have just one goal. And now we can just do exact that. That's one proof.
Yeah.
And now
Maybe we do it with ors
I
instead
think
of ands.
we can try to mimic this closer where we now I want to split this. I want to show that split is a thing.
Right.
Can't remember what that is.
So if you do constructor.
Yeah, let's try that. Yes, yes. Okay. Actually, it's also apply.
Or we've got an and.
No, you have to choose.
So it's constructor, yeah.
But which constructor did it choose? Like, it chose both.
Yeah, because we need to show both A and B, B and A.
Yes, but wasn't there like a way to do it like, you know, like this? But I don't think so.
I know, but that's for ors. Again.
Yeah.
So our goal is an and.
Oh, it's an
So
and.
you need to give both B and A. You need to give both left and right at the same time. If you do this constructor, then it splits in the goal. So then it gives you two cases.
There we go.
Yeah.
Intro. That's the. Yeah, because that's the same as constructor.
Mm-hmm.
And there's no such thing as split. But actually, I think split is kind of apply and intro, because split is only applied on end. What do you think?
Yeah. There's no. I suppose the closest thing is constructor. If you wanted like a general tactic, it's going to work for that destruction.
And then you can do case
the
left.
Goal. Yeah, exactly. But that's with the or. So. Yeah.
Oh, no. This was an intro here.
Okay. Yeah.
See, yeah.
So that left is just the binding the case. You end up with two cases, and then you call it anything.
And this
is that right? So you could call it left and right. That left. There's just an identifier, is it? It's not a.
No.
Okay.
It is the left and right fields. Okay. Yeah, which fields? What is the? Just want to comment this. Come on. There we go. Okay. And then we go exact H1 or H2. Exact H1. Yeah.
Yeah.
It's maybe also worth mentioning that the split tactic in Lean, that there's also a split tactic in Lean, but it's like it's doing something else.
Aha.
Yeah.
That is worth
it's
noting.
for breaking up match pattern matches or what is it, if then else kind of things that you where is it? I saw
so it's saying here it's if n equals 0, then q else r. It will split into two hypotheses: one where n equals 0, and then the if branch, and then the second goal with not n equals 0 and the target else branch.
Okay. I think we can just mention it's a different tactic.
Yeah. So false friend.
Yeah. False friend. where are you? There you are.
Line 8. Yeah.
Okay. Intros, I think intros needs to name every variable parameter.
Or every hypothesis.
Yeah.
Oh, well, I mean, you can use it without naming anything, but it will bring the hypotheses into scope, but they're given those magic names. I think.
Okay.
Yeah.
Yeah.
So you can't refer to them.
Mm.
But yeah, if you want to refer to them, you need to name them. Yeah.
Hypotheses. There's a typo. Okay. Yeah.
Yeah. I think I'm going to go with this just to keep it short. But you are
Yes, because that's usually what you want to do. If you want to replicate the behavior of Coq, then you need to name everything.
Yeah.
Yes.
Okay. What else did we learn from this? Cases.
Yeah. Destruct.
Even I would even put that here as well.
Yeah.
Obviously some cleanup needed here, but
yeah,
just we've covered it. Intros we've covered, and split and destruct. Yeah, and exact. I think we can say exact works exactly.
yes.
Okay.
And then there's also assumption works the same. We could have used assumption, couldn't we, in both the Coq and the Lean?
We assume. No, your assumption.
Yeah, assumption as assumption works the same is correct. Yes.
Works the same is correct. There we go. Okay. Okay.
Yeah.
Yeah, let's try another
after
one.
After the full stop, you should write assumption. Because that's like the assumption that the assumption works the same. And then period assumption. Prove it. Yeah, anyway. It's too much.
Yeah. Okay. All right, let's do a number now. Like a number one, as Gregor suggested. Let's see which one is. This is just assumptions. It's not so. Intros. Search rewrite. Oh, that's. I don't know what to do about that. But,
oh, I know what to do about that.
yes,
but it's not. I've been looking at MathLib. MathLib has a whole pile of tactics, including find and find. Yeah, so you can actually search. You can actually do the search rewrite, or the search in.
Yeah.
Oh wow, that's nice. That's good to know.
Yeah, it's really nice. And you can do well. I was going to save this for later, but this is pretty exciting.
Yes.
You can do things like instead of just searching, like you can in Coq, you can say it's also becomes a tactic. So you can say like by find. So it will. I mean, it's not.
Okay.
It's not brilliant, but you can, instead of just finding, you can actually use that as part of the proof. Yeah.
Okay.
So,
Okay.
but this is in MathLib, so you need MathLib 4.
You need it.
Yes, it's actually part of MathLib 4. But it looks like stuff from MathLib 4 can be folded back into standard. That's what from the documentation. But yeah, there's some interesting stuff in MathLib 4.
Are you sure?
So they have Ring, for example.
Or it sounds so familiar. Are you sure it's only MATLAB 4? It sounds so familiar. Like,
I saw it in MathLib 4. I don't know if it's elsewhere. It is part of Lean 3 because they're doing a lot of work to port over Lean 3 tactics into MathLib 4 because they're porting MathLib 3 to MathLib 4. So this is like, it was a natural part of the work for doing the porting to actually port the tactics.
Yes.
That's why they ended up in MathLib 4, I think.
Okay, yeah. I don't see it here. I feel like I saw something like this, but no.
Nope. They also, and something that really blew my mind was they have like a quick check thing. So
Yeah.
you can write down a theorem, and you can say by slim check.
Yeah.
And it will find a counterexample. If one exists. That's so nice.
I think Coq also has such a library. But it, yeah.
Yeah, it's called Quick Chick.
Yes, yes. But you have to install it, so
exactly. I mean, yeah, you have to install MathLib 4 as well, but
yes, but it's so standard. You also have to install the standard library, which means in Lean, so you're kind of already used to installing something. But MathLib 4 is a little tougher to install. Okay, but that's a nice to do.
Yeah.
Let's try the number thing. Sorry, I got
Yep.
That one was all about searching things.
So there's on page 18, they have this long expression that they need to rewrite, like using a bunch of rules.
Yes, but they're all like, it's really showing how to search, which, well,
yeah, well, since we can't do that, maybe it's not the best.
yeah, that's what I'm worried about. Like, I mean, this one is just assumption. Oh, there's something. Apply. There's no rewrite. That would have been, but it's two applies and assumptions. Here's some applies. Which is good. Oh, come on. But this number one, maybe, okay, instead of using rewrite or searching, we could prove some of these sub theorems.
Right.
Yeah, but I mean, they don't then we don't have the comparison to how it's done in Coq.
We're going to search for them and find their implementation, and then
yeah, we could do that.
2,000 references. That's good. Maybe theorem. Okay, everyone's class does this theorem, so beta gamma, no, induction. Here's one. This looks nice. We can do something else than pattern here. This one looks nice. How about this?
That looks good. Yeah, it looks very translatable.
Yes. And it needs plus a sock. That's the one it needs. Come on, did you? You didn't. You didn't. What a cheat. Can't believe this person. He didn't do plus a sock. Let's see if we can find someone else on the internet.
Wasn't there like a command to check within Coq directly for the proof, to show the proof?
Probably.
It was discussed in the in Coq
You mean the proof term or the?
I think, yeah, the whole proof, wasn't it just with search? Just with search, you can show
Yes, but
proof.
also here it is. Is that okay?
Okay.
I know it's there, but I just know it's going to take me longer to figure out than yeah, a GitHub search. So I got lucky. Let's just check if I did get lucky. Is this actually correct? Yes, okay, I did get lucky. Okay. That's whew.
It works.
Okay. Oh yeah, nice. We can also talk about semicolon.
Yeah.
Tactic operators, semicolon. Yeah, those are the only two I can think of for Coq. And this becomes, and this becomes just dot actually. Yeah, yeah, something like that.
Mm-hmm.
Yeah. Okay. So lost. Okay, here we are. We need to prove this in Lean. Okay, do you think? No, definitely not. Well, the intros part, I can work with that, but I only want that. Okay. Okay, now I got the proof view for.
You need a lean. Yeah.
Okay, you can run both at the same time. It's fine. It's all fine. It's all fine. Okay. Yeah, well, induction X.
Yeah.
As this? No.
Yeah, you can't do that destructuring, I think.
But no, you can. You just do case 0. Sorry. And then case. There we go. So this is x0 and x0 to be exact. Yes. Okay, and then this should be, hey, why? Where's the love here? Is this net or something?
It's like LaTeX nat, isn't it? Do backslash.
Oh.
Backslash nat. Yeah, over n, yeah.
Ah. What is that?
Sorry, AX.
That's not right.
You do induction.
It's a big net. There we go.
Oh, okay.
Or it might also be this, but
yes.
Oh, okay. No, it is different. Okay. There are two different things apparently. So Sorry, Paul. Sorry. So your place of
You're
disgust.
missing. Yeah. So what we're not introed enough stuff?
No,
What's
that's it. It's just the sorry that I took away.
Oh, okay.
So now, well, we can try riffle. No, that didn't work. Okay. So then sump. And that's it. Interesting. Also reflexivity, we already know that.
But there is a reflexes, isn't there a reflexivity
Riffle.
tactic?
Yeah, riffle. RFL.
Yeah.
We
It
didn't
work in this case.
Yeah, sump only. What was a D-sump? Was that
Oh yeah, I don't remember this. You have to let me open the
yeah, we did something with sump at, sump.
You do simp and then in square brackets you can do something. We use simp only as well.
Let's see. Sump only.
I don't remember what it does.
It only does the simplifications you give it, so you can go. But it still finishes it all for you. So
We also use dsymp only.
yeah, I
But
did.
we use dsymp only without a list. What were we doing there? I mean, not even with an empty list. We got some stuff with just dsymp only.
Yeah.
What does that mean? Is that a mistake?
No, it does very little. Sump only also does some, but it does very little. But yeah, I think this is gonna be sump, unfortunately.
Can't we use the rewrite tactic? Rewrite it using some constructor.
Yeah, we're just trying to like replicate this simple reflexivity. But yeah, we unfortunately the best we can do is just sump. We can't like break it into 2 steps because sump also does reflexivity.
Too powerful.
Yeah, it's too powerful.
Too
yes.
powerful.
But
Actually good to make here. So sump is kind of the same, but more powerful, as it includes at least reflexivity. Right?
But can't we specify maybe you were trying in the square brackets to restrict it to use certain tactics. Maybe we can just use the rewrite a certain rewrite rule.
Yes. But then it also does reflexivity after.
It's
I
still
think.
the okay.
Yeah. Which one did we have here? Sump only. Yeah. I think CBN is like dsump. It's the closest. Yeah. But yeah, That's
Maybe if
unfortunate.
it's just reading the documentation. If you say simp only and then give it a list,
Yes.
it's not meant to use the simp lemmas. So
Yeah.
but it doesn't work.
Well,
Maybe it doesn't maybe if the list is empty, it ignores.
But so isn't simple in Coq basically using rewrite rules, and wouldn't then the rewrite tactic, the RW tactic in Lean, be closer to that simple tactic in Coq?
No, I think it does some other stuff.
Does
Simple
other
does some other stuff as well. We don't know exactly how it's defined, but I think
because it's also
from
defined.
experience it does unfolding or something at least.
Yeah.
Okay.
Yeah. It's a bit magical, but okay. Simp is the closest. It's fine. And then we have this one. Oh, I did a sorry. Okay. Intros XZ, YZ. I didn't need to, did I? Oh, this one did an intro. Oh, okay. I see. Okay. What?
Why is it not changed?
Okay. Intros X. Okay. Okay. Fine.
Yes.
Fine. Okay, now we do read RW with which does nothing. Okay, why not? X0. Well, yeah. Why
Well,
would
the thing is that the induction hypothesis has not been specialized with our particular Y and Z for some reason.
Yeah, but also, like, this is in parens probably. So there isn't something to rewrite. Like, this rewrite is way too smart.
Yeah.
Okay, let's see. Okay, we're gonna at least spatialize it with Y and Z. Yeah, I think that did that. But we do also need to regroup this. Oh, that's such a pain.
We need
something. No.
we need that lemma about suck.
Oh, how painful.
Unfortunately. Nat Predler suck or something, wasn't it?
I don't know.
Something Predler suck or
this is close.
Yes.
It's kind of like if these two were swapped around and in the reverse. What is this? Here we go. Oh, suck add instead of add suck. Okay. Repeat.
Yes.
And then there we go.
Oh wow, it looks very different to the Coq Proof
Right?
This is a nice example, actually.
Yes, yes. This is very unfortunate. But we also found another tactic modifier, repeat, which is just repeat. Try, it's just try. These are exactly the same. I think, oh no, we want to double check that. Okay, how about like a 10-minute break?
Yeah.
Cool. See everyone in 10 minutes.
Okay.
See you then.
Bye. That's unfortunate.
What's unfortunate?
Oh, great. Oh, that's awesome. Actually, I had this Zoom window open with all my meeting IDs, but Zoom is smart enough not to share that even though I'm sharing the screen. This is...
Oh, brilliant.
Oh. Oh. That's great. Ah, so lucky. So someone just let me know that we haven't made enough inappropriate comments. So I think it's time to focus on the title for a small second. So I think I got a better title. Tired of old fat cock. Try a fresh, lean vegetarian. Now it's not inappropriate anymore. So
I like it.
okay. It's just you know, an ad against Nando's. Nando's have a good sense of humor, so I think it'll be fine.
Yeah, they are all always very edgy.
But yeah, they're not very keen on competition though, I think. So we'll see how this goes. I do really like their chicken. Like I'm really actually a big fan. But yeah. Anyway. Yeah, we did this proof. I don't think we commented about what we learned. I think I learned one thing here. Yes. That you do need to intro something before you can do induction.
And if you don't, you'll get some weird error.
Which you don't need to do in Coq. You just do induction when you name it. It's...
Yeah. What does Coq actually do? Does it
introduces
just pop introduces X?
Yes.
It introduces something that you can do induction on.
Yeah. And then here you can do, well, let's see. How they did this. They did like that. Okay. Okay. Then here we can say case 0, this thing. Right, this is kind of the same. What a pain. In Lean, you need to intro a variable hypothesis, a variable, before you can do induction on it. Yeah. Well, what else did we learn?
Rewriting Coq is
RW.
magic.
Also rewrite. Yeah.
What?
Yeah, you can do RW.
Yeah.
Which kind of finishes it, but you can also do rewrite.
Okay.
And then, now I come. There we go.
Can't they just synonymous rewrite in RW?
Doesn't seem so, because there's still more to do in this proof now.
Yeah, but I think
it wasn't before.
Yeah, it doesn't do the reflexivity.
Because in the Lean4 tutorial, it says in the section on rewriting, the rewrite tactic, and then in brackets abbreviated RW.
Yeah, so just looking at the code, it says RW is like rewrite, but also tries to close the goal by RFL afterwards. So it's the same as so RW is the same as rewrite followed by RFL.
Oh, okay.
Okay.
Well, it kind of try RFL technically, but yeah.
Yeah. And then I think you can just do, no, it's like this. Yeah. Oh, and you have to put it in brackets. So actually, where is it? Rewrite H is rewrite H.
Yeah.
Okay. RW H is the same as rewrite H followed by try raffle, and then this becomes
Yeah,
go.
with paren. Do you have to put parens around the around? No.
Yeah. Yeah, you have to, it's in here where you do the rewrite.
Ah, okay. That's fine. Yeah.
It also works. So we could actually even do this. And I think, can we? Yep. Yeah, that works as well.
Okay.
Maybe, yeah. Cool. And we had that other one, this one. It's not doing anything new. Like, yeah, we've done all those tactics. Oh, we can say rewrite is not as smart.
Yes.
I don't know how it's so smart though. Actually, let's check. Why is it so smart? We do dots here. Oh, sorry. Oh, that's why. So this was fine. So simple was the thing that grouped it.
Oh, okay.
So rewrite is the same. So
Okay.
yeah. Yeah. Can we do simple? No. If we add this, yeah, then it works.
Right.
Yeah.
Yeah, because that just looking at the list of stuff that simple has, it doesn't have that, but it has some stuff. So it has like lots of stuff with bool, if and only ifs, and then it has.
Oh, I think. Oh, look at this. Wait.
It only has one thing to do with natural numbers by
Open.
default. Oh, that brings a whole pile of other stuff in, does it?
Didn't import. What is it?
You have to import and then open it.
No,
data.net.
no, you can open it so it can find it.
Okay.
But it's not good enough.
Yeah, I don't know. Because in the default list of simp lemmas, it has one natural number lemma already.
Yeah.
But don't know how we ask it what lemmas it has.
Yeah. I want to do just do that. Nat.star,
Yeah.
No. Okay. We tried. I think we can also say with some. You can also do some uses the theorems in the list to simplify. And also all the usual theorems. Sump all does something else to do. There might be, there's another sump star. Does something else.
Yeah.
Yeah. I think these are all of them.
I think there's one more. Actually, there are a whole bunch of them. So you can do simp star at star as well. Simp. So you got simp at star, and then you got simp parens star at star, and then you can do simp minus.
Where?
On line 419.
419.
And then you've got 425. Simp star at star.
Okay. Yeah.
But the minus one, it simplifies the main goal target using lemmas tagged with attribute simp, but removes the ones named ID. So that says use everything except these ones.
Okay.
That would be useful.
Yeah, I don't think we need that. But we can include this one.
That's like.
And this one.
Yeah.
Also, what's used a lot in Coq is with arithmetic expressions is the ring tactic. Maybe it's also worth mentioning that. Probably simp covers that as well.
Actually, in Mathlib 4, they have a ring tactic.
Yeah. I don't think so. Yeah.
So that's another one we can cover in the Mathlib 4.
Yeah. So yeah. Okay. But yeah, we need it. It's here. Like,
yeah.
In Coq, you do use it a lot. It's so handy. Yeah. It's just great.
We didn't use Torto a lot, like tautology, but that's also in MATLib 4, but I don't recall using that.
T-auto.
Yeah, T-auto.
Auto as well.
Auto is like simp, I guess, because that's the one that's extensible. So you can add stuff to what Auto's database, and that's like, you know, you annotate at paren simp, and you can put stuff in the simp database.
I think you annotated by something
Yes,
like
at simp. Yeah, exactly. That's how you do it.
Above the theorem and importing it.
Yeah.
I'm gonna guess. Auto in Coq is like simp in Lean. Yes, it is also extensible. Same probably.
Yeah.
Maybe let's try discriminate and contradiction one.
Yeah.
I think they're the same. Let's see. Is there a shorter one where I can use contradiction? Here we go. This looks nice and short. So we have it in Lean. Now we can reverse it to Coq.
Okay.
We didn't use this one out. I'm gonna nuke it. Is that syntax? Oh no. What else was not equal? Was it?
Steal
It wasn't this.
Isn't it?
No, it wasn't that.
NEQ.
It's /. Oh yeah, it could be NEQ.
Backslash NEQ. Well, I think you first have to type the backslash. I think you have to type it at once.
I don't think Coq supports that. Like, no, that's Lean, but we also just do need this. Otherwise, it won't work.
Oh, are we in Coq now?
Yes, we're in Coq now.
So it's less than greater than, I think.
Oh yes.
Yeah.
Oh, I feel like list. Okay,
we need list.
Oh, small list. Okay. Yeah.
We need to import. Oh no, we don't. Okay.
Yeah. Okay. There we are. Intros H. Contradiction. Oh. No such.
No. Discriminate.
Isn't it discriminate? Yeah.
One or the other, usually.
Yeah, but I thought in Coq we had both.
Yeah, we do, but one is for the goal, isn't it? One is for a hypothesis.
Hmm.
Well, in Coq in a hurry, I can't find the word contradiction at all. Interestingly.
Here we go. Here's contradiction. It's a thing.
Mm.
There we go. This might be a nice one. Oh, yeah, because we need Leah. Oh, it's also nice in Coq is this. You can have them close by the tactics that use them. Okay. Opa. Okay. Good. Okay, so this we can recreate in Lean. Yeah, neck works there.
Mm.
And then we don't have proof. We have by. And
We'll need a.
what do you mean?
There's
What do
nothing there. What?
That's fine.
Oh. Is the error only coming down at the bottom?
Is there a common issue? Oh, yeah. This, no.
And the for all? Can you use the word or?
Yeah, there we go.
Don't see it. Ah.
Oh, it's still not there. Okay. Okay. What do you have to say? Unknown tactic. Okay, fine, but just ignore this part. How about that?
It's okay. So list is not yes.
Okay.
List dot length.
We definitely have length here, so open list.
Okay.
Can we do that here? Yeah. Oh, very nice. Very nice. And yeah, we're good finally. Okay. So induction X's with okay. Okay, so just and we don't have Leah.
No. But there is something in MATLAB 4 called linear arithmetic, which I don't know.
Okay.
The tactic called where is it now? Yeah, lin arith.
Like this?
Without an underscore. That potentially is the same, but
yeah,
we'd have to try it.
Yeah. Okay. Well, what else did we learn here? I wonder if we even need this. Yeah. Yes.
So yeah, using that MATLAB 4 thing, if you didn't know about that nat.0 LT suck, you would write apply ? And it would do a search. And then it would tell you try nat0. Yeah, with just apply ? Is the name of the tactic. and it would do that search, and then it would say try nat.0 lt suck.
Oh wow.
It's quite nice.
Yes.
So you don't even have to do that thing of, put the skeleton in of the thing that you're looking for. It will figure it out from the context.
Okay.
Yeah, there's one called apply ? And the other one's called exact ? And then the one to do find is also tactic, but you give,
That's amazing.
Yeah. I've just tried it on a few things. It does seem to work. The find is a bit wonky. It doesn't seem to work that well. And some stuff I tried to search for, it just kind of exploded and said, I've tried to look for too long. But the apply and exact, I think, are going to be more useful because they're more targeted. And it's actually, sorry?
Do you want to share your screen and show if you're comfortable?
Yeah.
Okay.
So, but I'm not streaming.
You're not streaming, but we are streaming. So if you share it, that's why I'm asking if you're comfortable. So that's
Yeah. No, but if I share my screen, it won't appear on the stream, will it?
It will share it to me, which will.
Okay. We'll do it by proxy.
So that's why I'm.
Yeah.
You need to be comfortable.
Do I share?
Well, it actually will just share by Zoom because Zoom can do all this. So I just unshare.
Yeah.
And then you can go. Cool.
Okay. So I was trying some stuff here.
There, it's on Twitch.
Excellent. So I was trying to find, the kind of distributivity thing.
Yeah.
But it's come up with lots of junk. So this is not so useful, I think.
Yeah.
But this one, I think, came up with something better. Yeah, so this I'm saying find all things that you know about with this type or with something that matches this type. It's come up with some stuff.
Cool.
There's also this use tactic, which because we're having problems with exists.
Yeah.
So this works more like the exist tactic in.
Oh, that's good.
Yeah, in Coq.
Where is exists? I'm just going to make a note. Mathlab 4 has a use tactic.
Yeah, and then here's the apply. So I've got this thing here, and I can say apply, and then it will say try this exact nat lt base x.
That's cool. Yeah, that's really nice.
And what else? Oh yeah, and here's the slim check. You can write down a thing and say, is this right? And then it will say, no, here's a contradiction. It's like a quick check. So you can just write that down. Wonder if you can, so what was it, LeanProver?
Yeah.
LeanProver will work here.
Yep.
Yeah. Okay.
Amazing. Okay, we tasted that. That's done.
So yeah, so this is Leah probably. Linear inequalities.
Okay, so this is all in the mathlab.tactic.
Exactly. So you just import mathlab.tactic. And they've actually got decent documentation there about how to install it. And also there's this feature of whatever the build tool is called. Lake, yeah. So you can actually download cached builds of dependencies, so you don't have to build mathlib.
Nice.
And they document how to do that as well. So it will download for your architecture just the cache build, because obviously mathlib is huge.
Yes.
And that just worked.
That's amazing.
So yeah. And they also have this left and right, because that's why I got confused earlier, because I was doing the wrong way. Instead of ands, I was doing ors.
Okay.
But this right is you can there's this right tactic from mathlib as well. You can select the right and left case like you can do in Coq.
Cool. That's great. Oh man.
Yeah, so it looks like there's a lot of effort going in. And I think why the theory about why it's so good is because, like I was saying before, they needed these things from maybe not the slim check thing, but some of this other stuff they had in Lean 3. And so in order to port across Mathlib, they needed to write all of these tactics.
Yes.
But they don't have stuff for lists. So
okay, ballistic is still
ballistic is still good, yeah.
Yeah, but we should also add the SMT solver they're working on. So
yeah, I think they have that as well in Mathlib.
Oh really?
I was just looking, they had a SAT thing. Solve violin. Oh, maybe I can't see it now.
Oh, there's also ring maybe.
Yeah, that's what I was saying. Yeah, there is ring. Yeah, there's the find stuff, find cases. Oh, yeah. Oh, SAT. Yeah, so there's some SAT stuff.
That looks too little.
Yeah, it's actually something different. But there's some other stuff like clear. They've got a thing that will clear. Maybe works a bit more like Coq.
Yeah.
That lets you clear given hypotheses and all the hypotheses depending on them. But they don't have anything like inversion as far as I can see.
Yeah, inversion is still a big one I'm missing.
Yeah. Oh, there's the use tactic.
Oh, see what it does. It's wow, okay. No. Yeah, it looks like a good tactic to have. I'm not writing that every time. Yeah.
Yeah. Yeah, so they're just using refine. But
and I didn't know refine was a thing. So
no, nor did I. So is that from the
is that like
it's from Lean 4 standard.
It's from Lean 4 standard. Okay. Okay, great.
Oh, I'm clicked on it. Now, hold on a second. Let me try that again. That I don't know what. Let me do it here and see where it goes. Yeah, this looks like it's from the standard.
Yeah, can we try to refine something? If you remove Lenareth and then do refine gap like parane.
Yeah.
No, plain, not parane gap underscore smaller than
like this
x plus 1.
It looked like refine takes a list of stuff.
Oh, okay.
Oh, and now natural holes. Yeah. Well, let's just see. Would it be this way? And then no. Yeah, I don't know.
We look at use again.
Yeah.
The use tactic. Yeah. Oh,
it does some stuff.
Oh, because it's like an exact where we need to. It might be easier to do it with that OR tactic, that OR theorem you have. And so where you say assumption,
yeah,
I think just say refine space underscore. Yeah, enter.
No.
Yeah, Yeah, just enter, and then what's the error?
Line 11.
Okay.
I don't know how to synthesize placeholder.
Okay, we'll go back to use again. Just see. Like, is there some weird syntax they have there?
Yeah, well, yeah. So if you look at use, it says like
Oh,
these angle brackets.
yeah, but that's just a
odd.
construct.
Okay.
We just need question mark underscore.
Oh, interesting.
Yeah. And then new line. And then we should be able to go exact something, but maybe you can scroll up on your info view. Like
It should be here. Oh, I see.
Yeah.
So it did do something.
And then we can say,
oh,
in this
nice.
case, it did nothing because you can remove the right, and then it will be more interesting. So then you can go what would we want to do in that case, though? But you want, like, it will do nothing if you just do refine underscore, right? If you do refine constructor and you just leave a gap somewhere, then it is more interesting. But
like or?
Yeah. Like you could do or intro right, I think.
Yes.
And then the question mark underscore.
Oh, question mark, yeah.
Is it the intro right?
Auto completed into R?
No. I think, sorry, no. I don't know if it's left or right.
Oh, I see.
No, what is the error?
Type mismatch, intro left.
Yeah, we want right. Yeah, we do want right. That's true.
That's type blah blah blah. Don't know. Add more question marks.
Okay, seems to work. Go down. Yeah. And now I can say exact L.
Okay.
Yeah.
So instead, could I have used use there? Use. No.
No.
No, it's not the same, but they're examples of with exists.
Yes.
Mm.
Okay, but this is good. So refine. Okay, let me just write that down. Refine. Instead of using underscore, use question mark underscore.
Yeah.
Refine or.intro, right?
If that's what I was doing wrong here, maybe I should have used.
Yeah, I'm wondering if one of those can be a plain underscore. If you do the first one, plain underscore. Yeah. Perfect.
So why is that?
The first
Because this is a whole, and this is something it can infer.
Yes.
Right. Okay. This is the type argument, I guess. The implicit. Yeah, the prop. And this is the actual hypothesis. Okay. What did this come up with? Nothing. Right.
Cool. That's great.
Yeah.
I think unfold is kind of the same.
Yep.
Then what is another gap? Inversion. we don't know.
Yeah, we don't know.
Subst, I think is just renamed to something.
Yeah, so there's subst. Well, there's a subst tactic. Substitutes each X with E in the goal.
Yeah, maybe it's already.
And then there's in the mathlib 4, there's substs.
It's subst vars in the standard library.
Right. Oops.
I think. Remember.
Yeah, so we have for that, don't we?
Yes, yes, yes. Okay, but yeah, we need an example of that. So I'm just adding it to do. Generalized dependent, we still need. And then I think we're done with the first draft, right?
Yeah.
Wow. Oh, we need. Okay. We still need apply lim case, and yeah, maybe.
So apply is the same.
Yeah, I think it is. And okay, maybe I should share again.
Yeah.
Just let's see. Share. Okay. Just one thing we already did. In Coq, you have discriminate and contradiction. In Lean, it seems they are both contradiction.
What's the difference in Coq? Oh, the one works on the goal, the other one on the hypothesis. Yeah.
Yeah. So
It discriminates on the goal, I think, and then
yeah.
Contradiction for hypothesis.
No, wasn't it the other way around?
No. Possibly. Oh yeah. Just looking at the documentation. Yes, you're right. So contradictions on the goal.
Okay, we do need generalized dependent.
Yeah, so I just looking, Katy did because we did an induction where we needed something like that.
Generalize and revert.
Revert. Yes.
Yes, there we go. Nice.
Made a comment.
This is revert. Okay.
There is a generalized tactic in Lean as well, though.
Oh yes, but I think that's for pattern. I think it replaces pattern in Coq. Like if we look at pattern, there's a tactic here somewhere. I never use this, so, but here we go.
Pattern.
So this is our state. It says here, X times Y is a pattern. So at the first one, it captures it. And then it says rewrite that so that it becomes 1 times this. No, so generalize is different.
So in the Lean manual, they have this example, 3 equals 3, and then they generalize that to x is equal to x. Yeah, there.
Yeah, so generalized looks like it works on equalities. So if you have E equals X, it will replace all occurrences of E in the main goal with X's.
Yes. I just remembered something, sorry.
Oh yeah, sorry. As it were.
Yes.
So generalizes for equalities.
But do we ever use that in Coq?
No.
I can't remember doing that. We don't do it in Lean, actually. Like it's just not the way we work.
Maybe we just didn't know about it, and maybe it would have been useful.
Yeah, I just
Who
don't.
knows?
I don't.
We're just not aware of that before. I'd never seen it before, but
yeah, because we're always like the theorems we have are all already generalized.
Exactly.
It's yeah, hasn't come up.
I'm not sure though whether it only works on equalities. It says that it replaces an arbitrary expression in the goal by a fresh variable.
I'm just looking at the documentation and the code.
I think it should work, right? You should always be able to go, there's this very specific thing, but I can always generalize that thing. It's like the reverse of taking a for all and specializing it.
Yeah.
No, well, it's funny though. If you're in the syntax only mention the syntax, like the grammar, it only allows equalities. I'm not sure what the documentation means. So you can say like generalize H, but the type has to be an equality.
I mean, maybe we can just try with an example.
Yeah.
Yeah.
We could like generalize an implication or something.
Here we go. Oh, this is Coq. Sorry. They look the same. Why do we write this like thing? Like, come on, people. Okay. Actually, we need to do this and say true. Right? And then okay, this is actually more interesting. Okay. Now we do this. Okay. Now we can say
Generalize H.
True. Right?
Yeah.
See, this is always an equality.
Yeah.
So we need to rewrite the thing to say generalize B and A. And then it doesn't recognize that syntax.
No, it's expecting an equality, especially equals. So each of the arguments needs to have an equal sign in it. That's how the parser works.
Can we say B equals true? No. Oh, true is also not a thing. No, it has to be. What? Oh, it's fine. It was fine. Okay, it was fine. And this is B unknown identifier. Okay, I feel like X was an unknown identifier. Okay, but oh, there we go. There we go. It worked.
Yeah, they're nice.
Yeah.
Yeah, and now we can say apply example 2. And no, exact. Come on. Okay, apply example 2. So we've swapped it around. But yeah, we don't have.
No, we've lost the fact that.
Yes. Okay.
Yeah.
Almost. Okay, but it works.
Yes.
Yeah. That's good to know. But yeah, I can't think of what the Coq tactic for this is.
No.
But it's interesting.
Yeah. I mean, there is a generalized tactic.
Oh, can we do this?
No, so that it's not the same.
It's a different B. Yes. Okay. Okay. Whatever. It works. It works. But yeah, I can't think of how we would use it in Coq. Specialize. This is also have.
Yes.
Then yeah,
there is a specialized tactic, separate specialized tactic in Lean.
Okay.
So it adds a new hypothesis and tries to clear the old one. So it's like have, but it will try to clear the old.
Okay. In here. Okay.
Yeah, so I'm just reading from here. It doesn't examples, but so you specialize, give the hypothesis and then the arguments. And then it will do have and then clear.
Okay. Cool. That's good. I think we've covered everything. Well, mostly. Now we need to just turn this into a document. But this is like, yeah, I wish I had this when we started.
Yeah.
Would have been like, even knowing how powerful Mathlab 4 is, like I would have prioritized installing it.
Yeah, but maybe it's when we started, it wasn't as mature as it is now. I think it's come. Yeah, like, I think the documentation for installing it was updated like yesterday or something. So maybe it wasn't very good until yesterday.
Yeah, I do.
I've tried to install it before, I know, and I failed.
Yeah, me too. Me too.
But this time I just blindly followed the instructions, and it all just worked.
Okay. Maybe I'll add that to the project just to have it there. And yeah, we could always use more tactics.
Yeah,
especially.
I mean, the tactics are only. I mean, it's mostly for maths, isn't it, rather than for tactics? But I was thinking we probably learn stuff from how they write the tactics. Although when I did a quick look today, there wasn't much there that you haven't already done, Walter, that I could see. Oh, but there might be something there.
Oh, I think use is already useful. Leah, like I really must.
Yeah, and ring, I guess.
Yeah.
And they even have like rewrite question mark, RW question mark, where it will just try to find the right lemma to rewrite.
Cool.
So there's more stuff like that, which I think is quite interesting, because I know there is that search feature in Coq, but that's sometimes quite difficult to use. Where in Mathlib 4 they have these question mark variants, which will just look in the context to find stuff that looks right, and then give you a list of alternatives if it can't find one.
I think that's really cool, and like that's how I would want to use an SMT solver as well.
Yes.
SMT question mark, and then get the this is. You could probably apply these tactics and it should work, and then you apply them and it works. So then you don't have to do the search every time.
Yeah.
I think that's how, like, Cockhammer.
Exactly. So you can just leave that there. You can say like by find or something, and it will every time. It might slow things down a bit, but I know when we actually do the proving stuff, I wonder how useful a slim check is. So to actually find like counterexamples if you try and write something down that's wrong.
Yeah.
Whether it can actually be useful.
Yes. Yeah, I do wonder. All
So
right.
I'm going to stop. Sorry.
What?
Are these question mark variants a little bit like more powerful variants of search patterns? So does it try like different patterns that the current goal could
Exactly.
be matched by?
Exactly. So the thing with the search rewrites and the search patterns is you have to provide the pattern yourself. Where these question mark variants are looking in your context for stuff that might work. So it's trying to find the shapes of things that, or looking at the types or suggest things that are already in the hypothesis. Oh, yeah. Wow. That's my understanding just from playing around today, but maybe there's more or less to it than that. But
well, yeah, I'm really glad you found these things. That's amazing. Yeah, I think we should just apply them as soon as possible.
Yeah, let's just add it to the library, add it to the.
Yeah. But yeah, I think we have a good start to a document here. So it's a bit of a mess to commit, but I'll put it on a branch and a pull request, and then fuck it, I'll just commit it. I'll just commit it. This old fat cock for the lean vegetarian. And then we just start updating it.
So we can take one and just add some examples, I suppose.
Yeah. But let's try to keep it short as well. But
okay.
Yeah, it's like this trade-off, right? So we want someone to be able to just skim it, and well, I guess a cheat sheet you should search through, right? You're gonna search for the tactic, so then actually having lots of examples is good.
You kind of want different purposes, right? So cheat sheets, you might want it to be an actual sheet, like a one size of A4, some kind of table.
Yeah,
and then you want maybe something more in depth. Because there's some of them which are easy, which are just like, well, it's just the same, or it's this other name. But then like the generalized dependent one, the revert one, well, you might not. Well,
that one's still fine, but like I think like even the struct here.
Yes.
Like I mean, you can do this. Yeah.
Maybe it would make sense to have like a very short and like a concise cheat sheet document, and then link the examples in separate files. So then one has like both advantages. one can like even print out the cheat sheet, but in theory.
Yeah, I see. Like if you are starting to prove something, this could be nice to print out and just have next to you while you.
Yeah.
Yeah.
Okay. Okay, yeah, let's try to make it a sheet with examples that are linked to yeah, a printable table, and then yeah, extensive examples as much as we want. Yeah, cool. Yeah, we'll start in the Katie that proofs repo and then maybe move it somewhere, probably. Except if someone has a different suggestion, but I just can't think of something. So.
Oh, it sounds fine.
All right.
Mm-hmm.
All right, someone new just joined, so it's a good time to stop the stream.
Yeah.
Hello, fourth person. Thanks for coming. Sorry, we're tired now. Hopefully you can join us next time. And yeah, but the punchline for the whole session is this line. So if you can read that before I shut down the stream, then it's all good. You got.
No, they've already left.
Oh, they've left. Okay,
Everybody left when you mentioned that.
that was really.
We went from 4 to 1, and I know I'm one. I'm the one person, so
I'm the other one. So
what? But it's only one.
Yeah.
I don't know what happened.
Maybe it doesn't.
There's
count.
obviously something odd going on with how they count things.
Yeah, it doesn't count me, I guess. So that's maybe what's going on. Okay. Yeah, I'm gonna goodbye everyone on the stream, and thanks for coming. Hope you learned something. I know I did.
Nice.
Wait, it's not done. It's not done.